today we're going to write the equation of the quadratic using information that we are given. And there are three methods of this. The first method says use vertex form. So we would use this method if we had the vertex and another point. So if we have the vertex and another point, I would use that formula. Now if we had the x-intercepts, and another point, then I would use intercept form. So we've already done problems with intercept form and vertex form. Now we're using them to write equations. There is a third method which we are not going to cover today. And that third method, if we were given 3 points, then we would write and solve a system of 3 equations with 3 variables, x and y and z. Remember that? We would do that if we had 3 points. We're not doing that kind today. See how excited you are. All right, example 1. So we've got, you guys can read the problem. We have data, and we're going to find the equation of the parabola that makes this data. We're going to find the equation of the quadratic equation that makes this parabola. That's what I'm trying to say. So we're going to look at this. Do we have the vertex, yes, or do we have the y-intercepts?
Vertex.
So we have the vertex here. So we are going to use the vertex form. So we have our vertex, which is HK. And in this picture, that vertex is 50, 35. We also have another point, which is XY. And in this picture, 0, 15. Now I'm writing down all my thoughts so that you can write down my thoughts, and then later you know where all these numbers came from. If you don't write it down, then you're not going to know later. We're also going to use the formula for vertex form. Y equals A, parenthesis, x minus h, close parenthesis, squared, plus k. So that's our vertex form formula. Plug in information. So I'm going to take the information that I know and plug it into the vertex formula. I know the y from my ordered pair, 15, equals. I do not know the a, that is how wide, how stretched this parabola is. I do not know the a value, so I'm going to leave that as a variable a. I do know x is 0 minus my h is 50, close parenthesis squared, plus my k is 35. So I basically plugged in the entire formula except for a. Then we're going to use our order of operations to simplify. Right, we're going to do the exponent, but, well, I'm going to do in parentheses first. 15 equals a times negative 50 squared plus 35. Then we're going to do our exponents. So 2,500 plus 35. And then we're solving for a, so what do I do next?
Minus A on both sides.
No.
Divide it.
No, don't you,
Multiply by the.
We are going to get rid of the furthest thing away from that A. The furthest thing away. Since it's being added, I'm going to subtract 35. Negative 20 equals A times 2,500. Divide by 2,500. Excellent. All right, on my calculator, I need for every single person in here to do this. On the calculator, I want you to divide those. Negative 20 divided by 2,500. Okay, I want everybody to do this, even if you already heard the answer. I want you to do this and hit enter and make sure that you got negative 0.008. Because then what we're going to do is we're going to change that to fraction form. And to change it to fraction form on your graphing calculator, after you have that answer, you're going to hit math. There's a button called math. And then enter, which changes it into a fraction. Negative 1 over 125. Okay? You actually do not need to change this one to a fraction because this decimal ends. But if the decimal did not end, then you don't round it. We don't want to round. So we would want the fraction instead. If you just want to put everyone in fractions so you don't really have to think about that, then that's fine. Okay, we have one last step. After we have found our A value, we're now going to rewrite the equation. We're going to write the equation using our vertex, which is HK, and the A value, do not plug in the XY. We're only plugging in the vertex and the A value into the original vertex formula. So we'll have Y equals our A value negative 1 over 125, parenthesis, X minus 50, close parenthesis squared, plus 35. So notice how I only plugged in the HK and the A. I left X and Y as X and Y. Yes?
Why is the whole fraction negative or just the?
You know, it can also be written as just the whole fraction, or it can be written as just the negative on top. You can't leave it on the bottom.
Well, yeah.
But you can also write it as negative. I just go fast and it ends up on top. But
I don't know if there's a difference in the math of it.
Nope, they end up exactly the same. Oh, that's great. Okay, so if you flip the page over, you will see there is a student practice. So you are going to try this. I'm going to zoom out up here so you can see all of mine, so you don't have to keep flipping your page over. But you can see all of the work, almost, all of the work up here, and then you're going to try it on your own. Okay, next example, if you look at the picture, we are given the x-intercepts. Here we go. Here's an x-intercept and an x-intercept. That is where it crosses the x-axis. So those would be our p and our q values. So our p would be 4, and our q, 24. Then there is another point sitting right over here. Please use that point. Use what they wrote. Don't just look at the picture and kind of guesstimate, because they told you exactly what that point is. So we have our x-intercepts, which are at 4 and 24. And then we have our point, our xy, which is 0, 9.6. And since we have x-intercepts, we're using intercept form. Y equals a times x minus p times x minus q. And then we're going to plug in the information. So the y value that I'm plugging in, 9.6. The a value, I don't know. That's what we're trying to find. We don't know how wide this is. Our x value is 0. Our p value is 4. Our x value again is 0. And then our q value is 24. So now we're going to solve that for a.
One on negative, or the subtraction of a
Yep,
point.
sorry, yep. There you go. Now we're going to multiply, so we're going to get 9.6 equals a times negative 4 times negative 24. So we're going to 9.6 equals a times 96. So a, we solve by dividing both sides by 96. A is what?
Oh, 110. Or 0.
Either 0.1, or if you type it in and you change it, you convert it, 1/10. Then we're going to write our equation. Remember, we put in the x-intercepts and the point. We do not put in the xy. So we're going to put in, we're going to start out by y equals, then our a value, 1/10, parenthesis, put x, minus 4, close parenthesis, parenthesis, x, minus 24. Done. There's a second question that goes along with that. Now, they've drawn a picture for the second question. I'm going to walk you how you get the picture. I'm going to walk you through the steps to get that picture, because you might have to be able to get the picture on your own. So I'm going to go through the steps of how they got the picture. I didn't put it up here. So I'm going to walk you through the steps. It says, what is the average rate of change in temperature over the interval at which the temperature is decreasing and increasing? So we can look at our graph and we can see that the temperature is decreasing starting when x is 0 all the way until x is, I don't know. The x values for this point right here, I don't know. It's not given. You guys have it on your paper, but I'm going to show you how to get it. How they get it. Exactly. So what this is this is the vertex. And a couple of sections ago, when it was in intercept form, and we had to find the vertex, we already learned how to do it. So now we are applying prior knowledge to this. So when it's in vertex form, when you have the P and the Q, how do we find the vertex? Does anybody remember? From like 2 days ago, 3 days ago.
You add them up and then divide them by 2. Then
You're going to find your AOS first. Right, Jared. We're going to take x equals P plus Q over 2. So I'm going to do 4 plus 24 over 2. Right?
Yep.
28 over 2, 14. So that's our x value. Then we plug in 14 into the equation. So we'll have y equals 1/10, 14 minus 4, and 14 minus 24. This is all review of stuff that we did earlier in this chapter. When you plug that in and you multiply it together, you get negative 10 for y. So our vertex
14, negative 10.
is at 14, negative 10. And they have that written on your paper, but this is how they got it. So what they're asking for is for the first part of this picture. Here, we're trying to find the rate of change from where it is decreasing, the rate of change. The words rate of change have to do with linear slope. Linear slope, which we did in chapter 1. We did slope in chapter 1. So the formula for slope, as a review, y2 minus y1 over x2 minus x1. This is
Yeah,
the slope.
I said y two for that.
So for decreasing, our slope, we're going to plug in our y2 minus y1. So our y2 would be negative 10 minus 9.6 over 14 minus 0 is negative 19.6 over 14, and that I would put in my calculator.
Which is negative 1.4 or negative 7 over 5.
Okay, I'm going to leave it as negative 1.4 because this has to do with a real life situation. That has to do with temperatures. And when we talk about temperatures decreasing, we're going to talk about like going down 1.4 degrees. We're not going to really talk about going down 7/4 degrees or whatever the number is. What fits, whatever the number is. Yeah, I wasn't listening to it. All right, so this negative 1.4 means that the temperature goes down 1.4 degrees Celsius per hour. That's what that means.
So that's for the hours from midnight to 14 hours
Right. Just for when it's decreasing. So for increasing, we're going to do the same thing, only this time for increasing, we're going from the bottom vertex all the way up to 24,0. We're finding the slope of that line. So we're going to do y2, 0 minus y1, negative 10, over 24 minus 14. So just doing slope formula, you guys did that since algebra 1. 10 over 10, which is 1. So let's interpret that. What does that mean? Temp rises 1 degree Celsius per hour. And then the last thing it says to do is compare the two answers. Which has a greater rate of change? Decreasing. Has a greater rate of change. So it gets colder faster, then it gets warmer.
Well, no, because that's just like at the specific times we're looking at, but if you continue the
But we
increasing,
can't
then-
continue because we don't know. I don't think it's going to continue forever, though. I think it'll come back down again, don't you?
Yeah,
I
but
hope.
it's
I
a
hope.
Unless we're
graph
heading
line,
towards the
and-
sun.
Global warming.
Okay, so this last example is you try, but if you look carefully, it says nothing about doing increasing, decreasing rate of change. This is only the first portion of it. It's just finding the equation. So start with question A. Don't do question B for this example. Let me pause it. So the answer for this one, if you want to go back later and look at it, y equals negative 5/8 x plus 2 x minus 4.